Advance is not working. So there are many environmental impacts from beef cattle, as well as any other, lots of different aspects of animal and other agriculture. In our modeling work, we do try to cover a wide range of these environmental impacts. Of course, the major theme today is greenhouse gas emissions. That's what I'm going to spend the most time on, but I am going to comment about some of the others towards the end as well. When it comes to sustainability analysis, life cycle assessment has really become the tool of choice. And that's what we work with, although we also connect this life cycle assessment to process-based modeling of the full production systems. And we're going to hear more about life cycle assessment later. To do life cycle assessment, just as an introduction, we have to consider all the major sources of impact throughout the ranch, the farm, the production system. But in addition to that, we have to look at what we call upstream. These are the impacts that would occur during the production of resources such as electricity, fertilizer, and that sort of thing that would be used in the production system. And we also have what we call indirect effects, substances, emissions from the farm, particularly nitrogen emissions, can go off and affect other ecosystems, and we want to incorporate those effects as well. So most of the life cycle assessment work for animal agriculture, particularly beef, has been what we would call a farm gate life cycle assessment. That's looking at everything that goes into producing the animals up to the time of harvest. And we've done a farm gate carbon footprint study for beef in the United States by dividing the United States up into, I guess it was 7 regions, and then modeling typical production systems within each region, and then doing a weighted average across the whole United States. And so the weighted total number that we came up with was 21 kilograms of CO2 equivalent per kilogram of carcass weight produced. And you can see there it varies some across regions within the United States and even more across different specific production systems that we modeled. The one consistent thing is that the large majority is, and we all know this, enteric methane emissions from the animal. Next in line would be the nitrous oxide emission that comes from feed production. You can see some of the other numbers there. So if we apply that number to all the beef cattle produced in the United States, including dairy cull animals, and compare that to what the EPA says is the total greenhouse gas emissions from the United States, beef cattle and everything related to producing beef cattle to the farm gate, it's about 3.5% of the US inventory of greenhouse gas emissions. So we also take that a step further now. We're going to go to the full life cycle of beef: transport, processing, retail, the consumer, and any waste created in the process and the disposal of it. So when we do the full life cycle, the denominator here is changing. So now we're looking at per kilogram of consumed beef. So the number goes up quite a bit at 43 kilograms of CO2 equivalent per kilogram of consumed beef. The important thing on this slide, I guess, is what's making it up. Well, close to 80% of this total is in producing the animal itself. And you can see the next block there is about 12% would be used in restaurants and the preparation of meals. You can see some of the other blocks there that are relatively minor. We add these in, now we're talking a little closer to maybe 4%, 3.7 to 4% of the US inventory of greenhouse gas emissions is related to beef. This is changing over the past 50 years, and the environmental intensities, that is the impact per kilogram or pound of meat produced, has improved. Currently, our cattle operations are producing about 20% more meat with about 13% fewer cattle. And that's also including cull animals from the dairy that are now being used more and more. So with our modeling, we can go back and we can model the production systems in 1970. and look at how they compare to today. So you can see the intensity there in 1970 was 31 kilograms of CO2 equivalent per kilogram of carcass weight compared to 21 today. But the total greenhouse gas emission related to beef cattle production, what we come up with is around 320 kilograms or teragrams of CO2 equivalent compared to 258 today. So what all that means is that the intensity that we're of producing beef cattle today is 33% reduction over 50 years ago. And the total greenhouse gas emissions coming from the production of animals has actually dropped. What we're estimating is to be about 19%. I'd like to talk now a little bit about global warming potential. And I think most of everybody here is familiar with the 100-year warming factors that are commonly used in relating methane and nitrous oxide to CO2 equivalents. And those numbers have changed over the years. I guess as we learn more and more, we're trying to refine those numbers. The numbers that I was working with and showed you were the AR5 without carbon feedback, 28 for methane and 265 for nitrous oxide. The current ones are 27 and 273. If we apply those different factors to beef cattle production systems, I guess, this is how it would impact them. And if we compare the AR5 without carbon feedback to the current AR6 that are now promoted, there's not a lot of difference. And even if we go back to AR4 units, it's just a small, the numbers would be a little bit smaller. You can see some of the others there are more profound, but this change in numbers has kind of confounded things when we want to compare studies that have been done over the years because these numbers keep changing. There's something else here that I think is more important to bring out. Cattle are part of a natural carbon cycle that has been going on since their creation. So carbon is taken out of the atmosphere as CO2, fixed in plants, cattle eat those plants, digest it, they excrete it. Some of the carbon comes out, in feces. Fair amount comes out as CO2 through respiration. And of course, some comes out as methane. And then we also have some methane coming from the manure. And methane is the culprit. But what's often overlooked, or at least not acknowledged enough, is the fact that methane doesn't last long in the atmosphere. It has a half-life of around 7 to 8 years. So within 10 to 12 years of the emission of this methane, it has gone back to CO2. Our cattle do not have a long-term impact on climate. A very powerful short-term impact, but not a long-term impact. So this has led to the development of a different model now that's referred to as GWP star. Here, warming potential is accounted based upon the change in the emission rate along with the amount emitted, over time. So when the amount of methane being emitted is constant through time, it's oxidizing in an atmosphere as quickly as it's being emitted, there's no effect. And even if we're emitting less methane over time, then we're actually sort of, in effect, adding to cooling of the environment, okay? So when we apply this model, the GWP star, and compare it to what would be typically used by our studies that recommended by the IPCC, you can see that the carbon footprint of beef would be reduced by about 50%. So it'd be about half of what we're actually saying today is the carbon footprint of beef. You follow that? Taking it a step further, if we were able to reduce the methane emission rate related to beef cattle production by just 1% per year, we could basically claim carbon neutrality for some time. Can't forever, But what it would mean is right now, if we were doing that, the so-called cooling effect by emitting less methane would offset all the emissions of nitrous oxide and carbon dioxide that are also being put into the atmosphere to keep things in balance. That's in the United States. Globally, the numbers are a little more sketchy, but FAO reports that we, compared to 50 years ago, 39% more cattle producing 78% more beef and 34% more greenhouse gas. So when you work that through our modeling, what that would imply is application of the GWP star globally would just reduce the carbon impact, the global warming impact by about 19%. So what can we do to reduce things, and how does that affect the system? We're looking at a lot of different strategies. I've listed a few here through more efficient feeding, using enteric methane inhibitors and anaerobic digestion and that sort of thing. We're also looking at things like use of solar panels, say on shade structures or roofs, nitrification inhibitors, and so forth. So a lot of options, and you may have some other ideas, and I'm open for more. What we can do with our model then, models are really good. These process-based models that I work with are really good at answering these what-if questions. So we're applying a lot of these technologies to, in this case, a feedlot system. And individually, we can get different amounts of reduction as listed here as percent of the total greenhouse gas emission from the feed yard. We can't just add all these up, but through modeling, again, we can look at all the interactions and put them all together in the model. And if we do that, we find that we could potentially, I'm not saying it's feasible, I'm not saying it's economical, but we could potentially reduce the greenhouse gas emissions from the feed yard by 50 to 60%. But that's not the whole story. We have to look at the full life cycle. And most of the greenhouse gas emissions related to beef cattle happen in the cow-calf operation and stocker and backgrounding operations, which also often depend on grazing systems. The finish operation only really contributes about 14% of the total greenhouse gas emissions in the beef animal's life cycle. So if we were able to reduce the feedlot emissions, greenhouse gas emissions by 50%, this would only provide us a 3% reduction in the carbon footprint of the full beef cattle production system. Follow that? So if we want to make a real impact, we really have to look more at the cow-calf operation and other grazing systems that would be used in beef production. And we're looking at those too. It just becomes much more difficult though, because what can you do for a grazing animal? I've listed some things here that we've looked at, we're looking at. And what we find if we put a lot of these together in a cow-calf system, well, we can reduce their emissions by maybe 8 to 10%. That is, we're reducing the full carbon footprint of the beef cattle by 8 to 10%. So it's something, but it's still very far from, say, carbon neutrality. And then what about carbon sequestration? Well, if we can sequester carbon in our systems, it can really have quite an offset. So I've listed sort of a range here from what might be possible to probably bordering not so possible. But you can see if we can sequester as much as 1 ton of carbon per hectare per year, we can get pretty close to offsetting the amount of greenhouse gas that is being emitted by the full cattle production system. How we can do that, how we can quantify that, and particularly how can we do that long term? I mean, we might be able to change our production systems and get that for a couple of years, but can we get it for the next 100 years? That's a big question. So I would like to kind of end here with looking at some other things. And I guess Dr. Mitloner brought this up earlier. We've got some numbers. I think one of the things that we have to maybe even be more concerned about is reactive nitrogen loss. We're releasing a lot of reactive nitrogen from our production systems. That's true for all of agriculture. This is for beef specifically. You can see here that a little over half of the total is going up as ammonia. A lot of that comes from feed yards, but actually there's just about as much coming from our pasture systems there is from the feed yards. And we also have nitrate leaching to groundwater and denitrification losses, which of N2O, which of course is a greenhouse gas. But ammonia is, I think, one of the more important ones. And if we compare the ammonia emission from our beef cattle production in the United States to what we estimate as the total ammonia emission from within the United States, it's about 30%, pretty high. If we want to add dairy on top of that, we're getting close to 50%. And with all of animal agriculture, we're getting probably close to 80%. So it is an important issue. And if we ever really get serious about trying to control it, it's a problem. Another one I think is not insignificant is water use too. Most of the water, and it takes quite a bit of water here, as you see, to produce a kilogram of carcass weight of beef. And most all of this is for irrigation of feeds that are going into the animal. And this is what we call blue water, which is non-precipitation water. This would be coming from surface water or groundwater. And if we compare all the water that's going into producing our beef cattle, it's about 6% of what's estimated as the total freshwater use in the United States. It doesn't look too bad, except that most of this water use is actually in the West. And that's where the water crisis is the worst. So again, I think it's an important issue. Fossil energy use is also an important consideration in any sustainability analysis. You can see here that most of the fossil energy that's used in beef production actually comes what we call the upstream production of resources like electricity, fertilizer, and that sort of thing. All total, it's not, it's less than 1% of what we would, what the total electrical or total fossil energy use is in the United States. What I feel is probably the greatest threat to the environmental and other measures of sustainability for beef and really all of our food system is food loss and waste. I think my numbers are a little more conservative than I think what Frank showed, but one estimate at least is that we would waste 22% of the meat that we produce in the United States. And globally, it's not a lot different. Again, I think it was mentioned that globally, it's more on the production end and less on the consumer end. What this means is that if we waste just 20%, this increases all metrics or measures of environmental and all types of sustainability by about 25%. And there's no other specific, say, emission or impact source that has that kind of impact. So I think this is something that we really do have to take serious. So take home, just to wrap it up, greenhouse gas emissions related to beef cattle production have decreased about 20% over the past 50 years while producing about 20% more beef. Good story. Major mitigation approaches are needed for continued improvement, and really there is no easy solutions. You can see the numbers I showed you. We're just kind of stirring at the surface of trying to really get somewhere on that. Beef cattle are a major contributor of ammonia emissions. And I guess I feel like this is not something to be ignored, and I don't think it will be ignored for much longer. The EPA has been grappling with this issue for years, trying to come up with some way to approach this. Water consumption, also a concern, particularly because so much of it is coming from our water depleted areas in the West. And finally, food loss and waste may be the greatest threat to the long-term sustainable long-term sustainability of beef, really, as well as many other, and maybe possibly all other foods. Thank you.